Um. Oh right, yeah. I forgot to ask. What's your preferred language?
Python.
Python's good.
Yeah, this version of Python's good. The
Perfect. All right.
3.1 or whatever.
Well, we'll just get started then. I mean, there's no need to dilly dally. So, welcome to the stream. Let's just get to the mock interview part right away. I'm not sure how many these you've seen. They're going to be an hour long. Typically speaking, we'll be given 45 to 50 minutes or so on the implementation. We're just skip right to that. All right, and we'll save 10 minutes at the end or so for questions, feedback, etc. All right, how's that sound?
Okay. Yeah, that sounds good.
Okay, so the question that we're going to be tackling today is about it's a problem called number of islands. All right, so you'll be basically counting the number of islands in this imaginary structure that we're going to be given. Okay, so your input is going to be a 2D list. All right, and it's a 2D list of booleans.
Of
It's a
Booleans?
yes, it's a matrix of booleans. That's right. Yes, and so 0 signifies water, and 1 signifies land. All right, and so an
Yeah.
island is has to be surrounded on all sides by water, or by in our case the border as well. So the border would also count as water, obviously. And so the goal here is to count the number of islands in our input.
Okay. Um, are there like any time constraints or like space complexity or time complexity constraints I should consider?
I wouldn't say constraints, but I would like you to optimize for time over space.
Okay. Um, then yeah, we can just get started. So like my thought process, I think is to like do some sort of like depth first search, um,
Okay.
where we kind of like given a specific index. From there we can traverse to see like which where it's connected, to identify whether or not like it's an island or not. Um, and then my other thought process was to actually, can we just clarify, like, say you have an island like this, um, like this would count as like one island, right?
Yes, that would count as one island.
And then like, what about diagonals? Like, are we considering um like this to be three separate distinct islands?
Yes, so in our case, this would be 3 islands. That's a good question.
Okay. So like, yeah, given that, are we like assuming that like, I guess this doesn't really matter, but it's like an m times n grid, correct?
Yes, it's n by n, so it's not necessarily square. That's right.
Um, okay. Yeah, so given like that, like I would create a DFS function as like a helper. And this would like identify um like the specific islands. Um, and then I'll have like the result, which would be the like the total number of islands. Um, and then I would iterate through the m times n grid by index. So starting from like the top row, um, and going through like every single column. Um, and then yeah, that's pretty much I guess my approach.
Okay.
Um, we could do like def DFS right here. I'll just press continue. Um, or I'll just type continue for now. Oh, this is only within a loop. Okay, cool. Not too sure how to do that, but um, yeah. So basically, I think like the first thing we're gonna do is within these parameters put like I and j, and this will identify like the specific index that we're at. And then we're gonna check if this value is equal to one, because you mentioned that one was land. Um, And then we're also going to check if it's out of bounds. Um, and then after that, we're going to, we'll just uh, recursively call this DFS, like for left, right, up and down. And then this one's going to be sorry. So like once we understand that this is an island, like this specific index is equal to 1, we'll change this to 0, so that like we don't have to iterate through it again. And then yeah, so I'll just do that. So sorry. Yeah, so here I just figure out the length of each side and then initialize a variable function called res. I'm gonna skip over the DFS function for now, and then I'm just gonna do like this for loop to iterate through it. Guess we can also just use I. And then here, this is basically iterating through every single um, position. If like grid I, j is equal to 1, um, we'll basically turn res plus equal to 1, and then we'll call our function for that specific position, and then we'll return res. And so that part, I think, should be good. Here we'll check if it's like in between bounds. So if I is less than 0, or j is less than 0, or I is greater than, I think this is greater or equal, yeah, greater than or equal to m, or j is greater or equal to n, or this will, yeah, so these set of if statements just check whether or not our specific position is going to be out of bounds. And the reason we have to do that is because we're going to be traversing through every single position if it is a 1. And so, yeah, we still have to make sure that it's like in bounds.
Yeah.
And then instead of checking whether or not the value is 1, we're going to check if the value is 0. And then we can just instantly break from that call. So instead of break, we'll just do a return because that's not allowed. And so, yeah, so given these if statements, we are guaranteed to know that this specific value is not water. If it, and not water and in bounds. So after that, then we'll change just water. And this will basically just be like, okay, you can't traverse through here anymore, and that if we do see it again within like this list, while we're traversing it, we won't have to recount it. And then, yeah, just, I guess, just call it from here. This one's for the right. This one's for the left. This one's for up, and then this one is for down. And I think this is the final answer. I guess we could do return here, but
Okay. Do you want to walk
do you
through an
want me to run
example?
this? Yeah. Okay, so say we're given like this. Um, so we'll initialize this, so it's length 3 and then length 3. And then for I range 0 to 3, which will just be 0, 1, 2, and then this will be 0, 1, 2 as well for the j, because it's at 3 by 3. Um, if this one is equal to 1, so it is equal to 1 at this point, um, we're going to increase res by 1, so res is now equal to 1, so we've identified one island. And then we're going to go through, actually we'll go through the DFS first, and then we'll do res plus 1, but um, we'll do, so I is not less than 0, it's not less, j is not less than 0, I is not greater than m, j is not greater than n, and it is not 0, so now we change this into 0. We go through the DFS on each side. If we do DFS here, this is going to give us 0, or this is going to return. If we give this, that's 0, so it's going to return. It's going to be out of bounds if you go up or to the left, so that'll also break it. And then it'll return. So then we're at res plus 1. Now we're at the next spot, which is this. And so it'll skip that just because it's not equal to 1. And then this one, it'll do the same exact thing. So it'll DFS. It's less than 0, less than 0. It's not greater or equal to m. It's not greater or equal to n. And it's not 0. So we'll change that into 0. So again, it'll be like this. And then it'll return through DFS. This will still, it'll still check for this. Understand that it's not, all the positions are not equal to 1 or is in bounds. And so it'll turn res into 2. And then after that, same exact thing. Here's the 0. It won't execute. This will execute the same way. It'll DFS through here. It's not less than 0, it's not less than 0, it's not greater or equal to m or n, and it is 1, so it'll skip this if statement, changes it into 0, DFSs through it, there's nothing surrounding it, and it's not, there's no ones around it either, so it'll just turn that into 0, and then after that, it'll turn the result up to 3, and then basically from here on, this will be 0, this will be 0, this will be 0. So within this nested for loop, it won't execute. And then as a result, it'll just return res because we iterated through everything.
So what's the result in our case?
For this, it would be 3.
Okay.
So, yeah.
All right. So what's the time and space of this implementation?
So the time complexity of this would be so the for loop itself is O of n. Because it's going like 1, 2, 3, 4, 5, 6, 7, 8. So it's going through the entire input size. So I think this for loop is ON.
What is n?
Okay, yeah, you're right. Sorry, n is one of the sides. So it would actually be n times m.
Okay. That's the entire time
For this,
complexity? Okay.
no, just for this for loop. And that's because it's iterating through like everything. And it's the size of the array or the 2D list. The DFS function, however, would also be at worst case scenario, like it would literally have to iterate through everything within this. Um, so it would be like times, um, like say you're here, it'd have to go through here, and then it'd have to go through here, and then it'd have to go through here. So then it would also be n times m, I believe. Um, and so I think this is the top complexity of it, but I'm not too sure.
Okay. And the space?
The space would be, um, like since we're not making anything, um, it would just be constant, I think. Just because like we're really only initializing the res, and then like using that as a tracker. So that's like the new data allocation. So I think it's just O of one.
Okay. Um, well, allocating data, like you can allocate data without like calling new variables, right? Like you can also allocate data through other means. So
Um,
it's so it's,
yeah,
so the
you're.
reason you think it's O1 space because you aren't allocating data is that just a reason?
Um, well, I'm just thinking like the output's gonna be the same regardless. Like we're just returning res and we're just using res as like a counter,
Yeah.
and that there's no new memory allocation. That's what I think.
How about these calls over here?
Where are you? Oh, yeah. I got no idea. I honestly think like, I just refer to this as like the time complexity, but
Okay.
um,
Okay. Sounds good.
that is that like I don't know.
All right. So now let's say that we don't want you to mutate the input, right? Let's say like I don't want my consuming functions to be modifying my input. How would you handle that in this case?
Sorry, can you repeat that question?
No worries. I don't want you to change grid.
Yeah.
That's the
Okay.
new problem.
Um, if you don't want me to change the grid, instead of like saying, okay, grid I and j is equal to zero, like we just have to figure out a new way to do this. This would probably take up like more space complexity, if you're not turning it into like zero. So my thought process is like you could use some other data structure to kind of keep like in track whether or not like we've already visited it. And like the best way to do that is probably like a set. Um,
Okay.
the reason why is because I think like you can access set in all one time, and additionally there's no duplicates within the set. So that'll help us to like really identify or easily identify um, whether or not like we've seen it before.
Okay.
And so like as a really as an implementation, like you could do visited is equal to set, um, and then instead of saying, okay, so instead of saying, okay, is this, have we visited this before? Because this is basically like what it's doing. This piece of line is saying, have we visited this before? Or else like it would have never executed like here. So if like ij um, in visited, you could just return, and then instead of turning ij into zero, you could just do visited dot add um, like ij.
Okay. And so what would this change in time complexity or space complexity at all?
This I don't think would change the time complexity. Um, yeah, just because it's like already like the lookup time, I think within a set is already like fast. So it would be the same as like knowing the index of an array. Um, so the time complexity wouldn't change, but the space complexity would definitely change. Just because we're adding like this new set, which is like visited, and we're creating this new set, and we're kind of allocating like new memory into this visited, and the visited would be the size of like n times m, which would, like, at worst case scenario, this set would literally have every single element within the array or within the 2D
Yep.
list.
Yep. Okay. Okay. So the time would remain the same and the space would get worse. Is the
Y-
conclusion here?
yeah.
Okay. All right. Sounds good. Um, now the next follow-up. So the next follow-up is going to be a bit more involved. So I'm going to set this up for you. So you now have a function which can count the number of islands in a grid without modifying the grid. Okay?
Hmm.
So let's assume that it works correctly. For the next question, we're going to be using this function for a bigger problem. So this problem is essentially the same. I'm going to give you a grid, to count the number of islands, but I'm also able to add land or water. Okay, so here is how this is going to look like. Okay, so if I just help you out here, so you are to write me a class. Okay, and you can do what you need here. Okay, it needs to have a constructor, in which this one I will pass you a grid, like you have above. Okay, and you need to also support a function add land, add ij, add water, add ij. Oops.
Hmm.
Okay, and then at any point, I can call count islands. Okay, so
Okay.
I want you to write me a class that can support add land, add water, and at any point, I can also call count islands.
Okay. Um, are there any like constraints that I should be considering with this
Uh,
question?
don't worry about the constraints.
Okay. Um, then like my thought process is like, so that you don't want me to implement def count islands, right? We are
I mean,
assuming
you
like
can
this
implement
already
it again
works.
if you have a reason to, but I'm allowing you to say that you can assume your implementation is correct and it works.
Okay, so then I'm gonna skip out on the def count islands for now.
Sure.
And then like I'll work on the initialization for the constructor and then the add land and then add water. So like my initial thought process is that like if you're creating a constructor and like you're inputting a grid into it, like that object needs to have like its own grid that belongs to it. So uh, basically, I think I'm just gonna like initialize it like this. So then now we have this new like self dot grid which belongs to that specific object. Um, and then I think add land, since it's made up of Boolean functions, um, and we're given the index, I think we can just directly access the index here and then turn that into land. And then in the same way, wait, self is not defined. Okay. Am I able to put self here?
Yes, you do actually need stuff in all of them. I just was lazy.
Okay. And then in the same way, like if it's gonna be water, it's just gonna be like this, and that's gonna be equal to um, 0 because we're given the index. Um, and then yeah, I would just keep the count islands the same. Um, yeah, I don't know.
Okay.
This seems like, am I missing something? Like I just feel like this implementation would work like
No, I
exactly how we'd expect it to.
let's start with that for now then. Okay.
Okay.
So given this, what would be the time and space complexity for each of these functions?
for each of these functions, I honestly don't know the space and time complexity of like the constructor. Um,
Well, so if all you're doing is setting it to grid, right? So this will just be constant time. You're not doing anything with it,
okay, that makes
right?
a lot of sense.
Okay.
Then in the same way, like the add land would also be like constant time since we're
Okay.
given the index.
Yeah. And obviously this is the same. Then it's the same as your definition above. That being said, you know, this is I mean this would work. This is a naive. It's a naive approach. Are there
Mhm.
ways we can optimize this, right? And the intuition here is, well, if we only change the grid by a bit, you can imagine, for example, we can initiate the grid, we call the count islands, that's the same
Mhm.
complexity as before. But if we just add one piece of land and then call count islands, it, you know, intuitively it shouldn't take as long,
Mhm.
right? Like it's almost the same. So
Yeah.
for this what I'll do is I'll remove the add water. That part will add confusion. So that's not a requirement anymore. We will not be able to add water, but we can add land. Okay.
Mhm.
So using your current idea of the implementation for count islands, what do you think you can change to leverage the fact that adding land isn't that big of a difference?
Okay. Um, I think I kind of get like what you're trying to get at. Um, like I guess if you could help me to clarify the question a little bit more,
Sure, yeah.
like
So, if we look
or
at
if
your
this,
go ahead.
sorry, go ahead.
No, no, you go.
Um, I'm just wondering um like if your thought process had me as count islands to be like constant time. Um,
I
and
mean,
then like we fit we fit the count islands, like we fit this implementation of count islands like somewhere else. Like for example, like if you had like self like number of islands here, right? And then this
okay.
would just return self number of islands.
Sure, yeah. I mean that's pretty creative. That wasn't what I was getting at. What I'm getting at is if we have this input, right, and then we call something like, is land counter equals, and I won't call that in obviously. Um, oops. A big thing here is, you know, at this point, yes, you could count the number of islands at the init. That's fine. It doesn't really matter. But the thing
Hmm.
is that if I were to, somewhere down the line, right, I do, let's say, island counter dot add land, and then just say for our case above, let's say add land at here, which is 2 2, right? So 2 2.
Hmm.
When I do this, from your perspective, when you're processing this request, you should be able to know that these guys didn't change,
Hmm.
right? Like these rows were not affected at all.
Yep, that's
And
true.
so, afterwards, if I were to call, island counter dot count islands, oops. You should like this should be faster to process. And optimistically
Okay.
speaking, if this was an in by in grid, you can imagine like a very large grid, and you only change
Hmm.
one value, it should take relatively constant time to process
Okay.
because it wouldn't have
Um,
affected any other rows or columns.
yeah. Okay. Just it's just like then there would be some like different implementation of count islands than the one that we used like previously, right? Um,
Yeah, you would likely need to change it to take advantage of that. Yes.
yeah, because like if we kept the same functionality for the count islands, like I don't know, maybe I'm missing something, but I couldn't see how like because it's a brand new call for the count islands and it's recounting it itself. Um, and if
It is recounting it. Like if you really want to keep. So yes, there's a couple ways to tackle this from this point onwards. One simple one is to think about what this means given your current implementation of count islands. For
Mm-hmm.
example, if I insert land at any point, you could actually break that down into four cases. Let's say for the sake of simplicity, this is the original grid. I'm gonna add,
Mm-hmm.
I'm gonna add at 1 1. Okay. Oops, that's not how I say 1 1. And add at 1 1. Okay.
Mm-hmm.
This means that there are essentially four quadrants of squares or grids. There's the top left of 1 1, top right, bottom left. Okay.
Yep.
Those are all valid inputs to your current implementation of island counter,
Okay.
right? Like do you see that?
Um.
Like you could input the top left of 1 1. So in this case, it's just 0 0. Obviously, a small square, right?
Yeah.
This is a valid input to your current implementation of count islands,
Yeah.
and the top right
Oh.
is also
Okay.
a valid input to count islands.
Yeah. Yeah.
So you got four valid inputs to count islands, and then you can quote unquote glue them together by processing the middle row and the middle column, right?
Hmm.
So you can
Sorry.
see. Okay, go ahead.
I'm a little lost. What do you mean when you're saying like there's four valid inputs? Are you
Yeah,
not just talking about 1 0 1? Isn't that only two
yeah.
valid
Well,
inputs,
so
or where are you highlighting?
yeah, so what we can do here is if we're inputting land at 1 1,
Yeah.
you have essentially, yeah, there's the top left of the 1 1 square, which is 1,
Yeah.
right? This
Yeah.
this is represented as 1, like this. Okay,
Mm-hmm. Mm-hmm.
this is a valid input to your current count islands,
Of course. Yeah.
right?
Yes.
This is a valid input, and you can do this. Well, I won't do it that way. You can do it 4 times, right? Top right, bottom left, bottom right.
Mm-hmm.
Okay, well, obviously, we change the variable names, but you can do it 4 times. Okay, now to now you can't do it naively like this because you got to glue the top side together. So, for example, this might double count, so you can't just like add these together. So this might double count. So you need to look at the middle one, the one between the top right and the top left. There's going to be one column above it that you might need to use to, for example, join this together. For example, if this was 1, this returned 1, this returned 1, and you can't just add it together because then you get 2. Right? 2 is wrong.
Yeah.
This
Even though it's
answer is 1.
one.
Right? So you
Okay.
would need to process these two together. And likewise, you would need to process 1 x and y together when you calculate that.
Uh
Right?
huh.
So, well, what's the benefit of this? Why am I telling you to break it down in this case? Well, you're breaking it down because this time complexity is quadratically better than if you just passed in a 3 by 3 matrix into your count islands. Right? Because
Okay.
instead of doing n times m squared in your case, which is I'm going to talk about what's squared. Well, I'm going to talk about that after. But instead of doing n times m, you're doing half n times half m plus half n times half m.
Okay. So like, are we basic like I understand like a little bit,
Okay.
but I'm still kind of lost on really like how the implementation would work because the count islands like it would have to change. There would like would it not have to like have a whole different section that refers to like this part? Like okay, if we add one, like let's check the right, let's check the top, let's check the left, and then let's check the bottom. Like if there's any ones near there, like that would connect. And then that would make it one island.
Yes. All right. So what we're gonna do here is we're gonna pause. We're gonna do a separate problem. This is a mock interview, so I can do this. Okay. So
Okay.
we're gonna move on, and we'll get back to this on the in the feedback. All right.
All right. All
This
right.
the second question we're gonna do today is gonna be. I had this one prepared, but I closed it. Sorry. This is gonna be called find bipartite graph. Do you know what a bipartite graph is?
No, I don't.
Or sorry, it's defined as is. Sorry, I said it wrong. All right. So let me go to the drawing mode here. All right. So on the left side, do you see the drawing button? I'm assuming you see it. Question.
I see it. Sorry.
Okay. So
I see
okay.
it.
So you can see me, right? I'm drawing here.
Yeah.
Okay. Great. Okay. So a graph is bipartite if you can. So let me just draw just a random graph here, just to keep it simple. Let's do this. And by the way, these are undirected graphs. Okay, undirected graphs. Okay.
Okay.
So
So does that mean they can go both ways?
yeah, so the edges can go both ways. Yeah.
Yeah.
So the definition of a bipartite is if you can, however you want, partition the nodes into two sets. Okay.
Mm-hmm.
So let's say this is my graph, and I want to make a set. I'll make this pink, and I'll make this one green, and all nodes must be in a set. You like so you can't have like any like missing nodes or anything. Okay.
Okay.
So if you can somehow invent two sets to put the nodes into, and there are
Mm-hmm.
no edges within nodes of a set, then the graph is bipartite. Okay. In other
What do
words,
you?
all
You're
edges
referring.
must be connecting nodes between the two sets. So you see how this edge
Okay.
is valid because it's connecting nodes between two sets. This edge is valid, and this edge is not valid. So this graph is not bipartite. And if you just look at it for a bit longer, you can prove to yourself there's no way to make this graph bipartite, no matter what two sets you pick. You can pick this set and this set. It doesn't matter. There will always be an edge that is invalid. So this graph is
So
not
the
bipartite.
sets like can't connect to each other.
No, so the sets are disjoint. So you cannot have sets like this, for example, and you cannot have sets like this. So all nodes must be part of a set, and the set's gonna overlap. So it is perfectly split. But they don't have to have the same number. You can have any number of them in each you want. You just can't have nodes that are not in the set.
Okay, can you give me an example of one that is
Sure.
that?
Oh, sorry, I'm gonna do this. This graph is bipartite because there does not exist an edge that connects two nodes in the same set.
Okay. So very quickly, um, does this just mean like mm, there's no connected like there's no loop within these bidirected nodes. If there is a loop, like you would return false,
Yep. If
right?
there is a loop, you would return. I mean, that's one way to think about it. Are you? Is that a guess, or do you have a? Like, is that a guess, or do you
I'm
have? Well, here's a. It depends. How you define loop,
I'm
because
just like
like, do you mean
clarifying
loop as
for
in like this, or do you mean loop as in like this?
uh well they're bidirectional, right? So the
Yeah.
first one
Yeah, I'm
wouldn't
just
even.
clarifying because loop, like, if you mean this loop, yes, it is possible to be valid, right? So what you can do, you can have a graph like this, and I define this to be a set, and then this to be the other set.
Oh, okay.
So I mean, okay, if you mean this is a loop, then no, I'm sorry, yeah. So this is not valid. I mean, I'm sorry,
Then
this
like a
is a valid bipartite graph. So I mean, your theory is not valid.
okay. That would it like what about like a how about like I'm just thinking yeah, like that would be one case, which would
Okay.
be like the three nodes um
Yeah.
that are like connected all each other within each other like through a triangle. Um
Mm-hmm.
but then does that like directly transfer to like because this is four nodes that are connected. So I'm thinking
Right.
maybe there's like a pattern there where like three of them might not be possible, four might be possible, but like maybe five that's within a set might not be possible. Or
Right. Right. I mean the right like the key thing here is right is you are to determine if a graph is bipartite, and the way I've framed it so far is to tell you, hey, if you can somehow produce the two sets, right? If you can
hmm
produce the two sets, then you can guarantee that it is bipartite. And that one I can't say like that's not a trick. That is true. However, that might not be the easiest way. Excuse me. That might not be the easiest way to implement a solution to check it, right? So this is just for you to conceptually understand, right? Um, do you have any intuition
Okay.
about how you might approach this?
Um, like, I'm thinking like the specific data structure that I'd probably use is um a hash map.
Okay.
And then like since we have a hash map, we're able to like know which nodes point to what specific other nodes. So if like the top left one was like A, top right was B, bottom left was C and D,
Okay.
like A would be connected to B, and then it would also be connected to D. Um, I don't specifically have intuition about like how I could even like identify the sets, but as of right now, this is like what I'm thinking. And then like maybe like I'll end up seeing it if
Okay. Okay.
if I
Yeah.
map it out like this.
Here's something, right? So, first of all, it's good to label the nodes. That's a good thing to do. What
Hmm.
if we, remember the definition? There's always going to be a set that a node belongs to, right? A node can't not be in a set,
Hmm.
right? And which of the two sets it belongs in is just a social construct. It doesn't matter. It doesn't care. This is something we're imposing onto the graph
Yeah.
to check a property of the graph, right? And so, what if we just say, I'll use blue. What if we just start at A, right? With a loss of generality, we start at A, and we say, all right, A, you are in set one. I just decided,
Hmm.
right? I decided you're in set one, right? Nothing wrong with that. And
There's
then,
nothing
well,
wrong
what
with
does that
that.
mean about B?
Um, B's allowed to be, or B's not allowed to be in that set.
Correct.
D's not allowed to be in that set either.
Correct. So B and D are both in set two.
Hmm.
And what does it say about C?
C's not allowed to be in set B or D,
So it's not allowed to
or
be
in
in
that
set
same
two,
set.
so it must be
Yeah,
in
sorry.
set one.
Okay, that makes a lot more sense.
All right. What if there's an edge over here, right? So now you have edge over here. So what does this say?
It's since it's not allowed to be like in set one and it's not allowed to be in set two, um, it'll probably like you'd probably just return false, since it's
Yep.
not allowed to be in like
And how do you
those
know
two
it's not
sets.
allowed to be in set one and two?
Um, like, well, you probably just check through like this. This is what like I was thinking, like using the hash map as a way to check whether or not like um
But how are you
it's
checking that?
next one. So say we're at C and then A also connects to C.
Okay.
Um, like you'd and C's pointing to A, D, and B. Maybe like it. Okay, so sorry, A, B, C. Um, like you'd go through A, and then like I'm thinking you go through A, check if B and D are in either sets. And if like that's not true, like put that into A, and then maybe like B, um, like we know that it's in set A. We know that A is in set one, and then we know that C is no doesn't currently belong to a set. So then you do like B, and then C. We know that like if we traverse through here, and then we say okay, A actually belongs to a set. Um, D doesn't belong to a set, but B belongs in in another set, like you just return false. Um, so I would just basically like you'd have to have a tracker, um, and traverse through each of these nodes. Um,
Okay.
that's my approach, but I don't know if like there
Yeah.
might be a better way to do it. But
No, let's talk about that. We're at the 45-minute mark, so I would like to, call the interview here.
okay,
We have a lot more to talk about, so I want to leave a little bit more on the 15-minute side than the 10-minute side today. All right.
yeah, let's
So,
let's do it.
so let's do it. All right. So, I mean, first of all, I always ask, how do you feel?
Um, like I feel like this question kind of threw me, um, like
The first one, the first
in a
question,
loop.
or the second one?
Oh, sorry, no. The second one was like super confusing to me
Okay.
just because I don't have like any. I've done like graph traversal problems, but always like new ones, I guess, are much more difficult to do without your guidance. So I didn't really felt like I performed the best.
Okay.
Um, the island counter one, like I've seen it before in the past, and that's why I was like able
Yeah.
to do it. Um, but then like the follow up with the set, I feel like that was like good, and I feel like that was the right answer to it. But then the naive approach, and like when you kind of went with like like segmenting them into four parts, I was a little bit confused on that. It was very hard to follow.
Okay.
Maybe it was just on my part, but other than that, like I think I did okay. Definitely didn't exceed expectations. I would say I kind of just met them for like a new grad.
Okay. 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 Let's talk about that. I mean, do you want to start with the second one or the first one? The second one, let's do the second one first. It's a bit simpler to get through. The second
Okay.
question, the premise here is I wanted to pick a question which you definitely do not know. I would because
Hmm.
I'll look. I'm a relatively experienced interviewer. It is blatantly, obviously new the first question, and that's fine by the way. That's fine.
Yeah.
But the reason you struggle on the second follow up with the first question was because you haven't seen that one before.
Yeah.
And so I was like, oh, well, that one was too hard. That one
Hmm.
is just too hard. And we'll talk about what the right solution would have been, how you would maybe consider approaching that from your level. We'll talk about that
Hmm.
after. But the second question was meant to be like, hey, here's a problem you don't know. Let me see where you actually get stuck on a problem that's more your level.
Okay.
So there's a couple things I saw, right? So I'm looking at the diagram right now. The first thing I saw was that you you were trying to think through this problem quite abstractly. Okay, when you're stuck about formulating an answer, the first thing you should do is stay concrete. So you should be drawing things out. You should immediately come with some base case examples. Okay, prove to yourself. First of all, prove to yourself you know what the problem is even about. Okay, like do you even know what this is about? Like does the interviewer agree with you on whether or not these two basic cases are bipartite or not? Okay, so that's the first thing.
Okay.
The second thing is okay. Well, how do you extend the examples? How do you extend the base case? Right? And there's a couple ways to frame it. This one might have been a bit more trippy because the bipartiteness is usually framed as whether or not a condition can be met. But this is not just a boolean you can call. You actually have to implement the underlying logic. And so
Hmm.
this is a language thing, right? Don't always get too caught up on whether or not let's say the definition can be directly one-to-one translated into code. You might need to
Okay.
think through that a bit more directly. And so, time wise, I just directly gave you the algorithm, right? And
Hmm.
so the goal then was like, okay, I'm gonna tell you exactly what you need to do, and now I want to see how you would translate that new idea into code or into some more understanding, right? And so I think that's probably where the weakness here, like in your process, generally is having a strong system for coming up with the initial idea and for translating your initial idea into something that you can actually implement, right? I
Okay.
think there were a couple of times in the interview that you had a good idea, but the idea was not, it's not valuable for interviews. It's not implementable, or it's not what you were given, etc. Right? And so,
Hmm.
and both of those are skills. They're related skills, but they're both important. Okay, so those are two things I'm going to call out here, just for you to continue practicing.
Okay.
Okay, but just to answer, your approach would have been correct if you had time for the second problem. Okay,
Okay.
so um, do you have any questions about the second problem here?
No, it's just like Yeah, just like as a retrospective, like yeah, I feel like I did need a lot of clarification with this question. So like in terms of like starting a question and I would say like it's kind of easier for me to read the question as opposed to like hearing it. Is it totally okay to just be able to like continuously ask questions to ensure that like you're like you understand the question fully?
Yeah, I mean that would be preferable actually. And the thing about interviews is, depending on the interview, you might be given it, like the question might be actually dictated to you, right? So sometimes I might just show you the writing, sometimes I might dictate it to you, and
Mhm.
the I won't get into reasons there, but many of the times it's because they actually will omit information on purpose, so you have to clarify it, right? Identifying that the problem is unsolvable is also a skill. Okay, so that is something which I would recommend you also practice if you can. And of course,
Um,
yes, you are expected to ask questions. For the problem like this, it's actually not expected. You know what bipartite is, right? So most people
okay.
who are asked this question, they don't know what it is, and that's actually by design. And that is, a level playing field. So now you need to also figure out the definition, and you need to figure out how to actually implement the definition. So those
Okay.
are all valid. Yes. So you should ask.
Then yeah, other than that, no questions for the second one.
Okay. So let's talk about the first one. Number of islands or count islands. Your first implementation is correct.
Yeah.
So nothing to talk about there. However, your time and space are not correct. Okay.
Okay.
So I'll briefly touch on this one. The time and space, the time of this one is going to be m times n. And the reason is because you will never visit a cell more than once.
Yeah. You're right.
Okay. Now, this problem oftentimes trips people up because if you just naively consider the two functions, like this one and this one separately,
Mm-hmm.
you'll get yourself into a little mix, right? Because this is m times n, and then for each m times n, you're doing a DFS,
Mm-hmm.
right? So it feels like you're tripping things up. But this is why it's important to understand the actual underlying data, right?
Yeah.
That approaching it from n times n nested with a DFS is one way to think about it. Another way to think about it is that you will visit every cell exactly once, or sometimes you might visit every cell exactly twice, depending on your visited check, right? And so
Mm-hmm.
that is actually a stronger argument for the correct time complexity. Does that make sense?
Yeah, yeah, that
Okay.
makes sense.
All right, so you can go brush up on that. Now, the space complexity here, your original one is also wrong.
Mm-hmm.
You said it was a constant time space. Um, the reason that's wrong is because when you make a recursive call, you add the call stack. Okay? So when you
Okay.
involve the call stack, that is memory which has to be stored by your algorithm.
Yeah.
So in your DFS, the worst case is that all islands are one, and so your worst case time complexity is also n times m.
Okay. Okay. Yeah, I think I just thought of it about it as like the res, and I didn't consider like the call stack. Um, yeah, I just didn't
Yep,
consider
yep.
that.
You got it. The thing with the call stack is that you got to consider it, right?
Okay.
There's no free lunch. For example, if I asked you to implement DFS iteratively with a
Mm-hmm.
stack instead of recursively, right?
Okay. Yeah.
It would then be obvious that it would be m times n roughly,
Yeah.
right?
Yeah.
Well, with recursion, you don't get a free lunch, so it's still m times n. It's
Mm-hmm.
just that you don't declare it instead. It's just implicit stack. Okay.
Okay.
All right.
Makes sense.
So whatever. Let's move on. Like that's not important. Now, the second part. This is a I would not say this is a common follow up, but this is a difficult follow up. Okay.
Mm-hmm.
And I mean like the dynamic problem. So this is a class of problem called query problems, where the underlying data that you're asked to perform an algorithm over can change.
Mm-hmm.
Okay. The optimal solution for this problem is using a union find. Okay. Are you
Mm-hmm.
familiar with the union find?
Like I know what a union is, but I don't know what a union find is. It's
Okay.
just like
Do you know
when
what a
two
disjoint?
sets,
Maybe where you're from is called a disjoint set. Have you heard of that?
yeah, they don't belong. Like there's nothing that in the middle that matches up.
Okay. So yeah. Not quite. I'm gonna have you look that up after. Okay. So union find disjoint set. Go search it up after. Okay. So
Okay.
now it's obvious the moment you start talking that okay that wasn't something which is in your toolbox. Totally fine,
Mm-hmm.
right? So oftentimes when interviewers are asking questions that are like not this question but questions like this, they know the optimal solution, and oftentimes for problems like this, it is the only optimal solution, and it is very obvious. Okay, and so what that means is if you don't read the question, you go like, oh, this is unit find, blah blah blah, then you don't know it, and that's okay. So
Mm.
then the interviewer is changing gears. They're saying, all right, okay, so if we're not using unit find, here's a more approachable solution, which I think is acceptable. Okay, so what is the actual thing going on here? Now again, I won't get into unit find. It's a bit of a mouthful to explain here, so you can go and search it up after, like I said. But the approachable solution was one I outlined here, which for a 3x3 grid doesn't sound very useful, but you have to kind of imagine, right? Why is it useful? So I alluded to this briefly. It's useful because you believe your current algorithm to be n times m squared.
Yep.
Okay, and so if you can have n and you can have m, that is, that's a like just an insanely large improvement. It's a 4x improvement on the spot, basically,
Mm-hmm.
right? And so,
Mm-hmm.
one thing that they can always think about now strategy wise, one thing that you can always think about when you have a naive solution is okay, naive solution. How can I break the problem down to be, fewer naive solutions, right? If you can break the problem down to be fewer naive solutions, then quite simply you get a relatively free improvement, right? So that's
Yeah.
one way to think about it. It's not like okay, well, I can't think of the optimal solution, or no, I don't think this is a big improvement. Well, what can you think of, right? It's strategy wise, it's never good to just sit there for too long thinking about something and not have something to show for it, right? So if you can just at least keep the gears turning and come up with something that is an improvement, that's good to kind of at least vocalize. Now, on the other hand, if you believe you're thinking about something and you think you're close to getting to somewhere that's actually quite a big improvement, like let's say asymptotic improvement, then you should also say that as well, right? Like, what is it about your a naive algorithm that's not appropriate? What do you think you can change about it? How does this new problem fit in,
Okay.
right? But if you're not getting there, that's okay. Voice any naive improvements you can think of, and get the buy-in from the interviewer, right? Ask them to comment in, ask them to chime in, see what they think, see if they can help, right? What you don't want to do is you want to sit there and just get stuck, even if it's a
Yeah.
hard problem, right? This is a hard problem. I know it is a hard problem, right? The goal here isn't that I want you to find the optimal solution. That is obviously not in this ballpark here, right? But what I want you to do is I want you to be able to walk me through your thoughts about why your naive solution won't do well or why it might do well, right? And how you might be able to use some sub problems, how you might do some pre-computing, anything of that sort,
Okay.
right? So just keep that in mind. That is something which it's not like all or nothing. It's not all or
Mm-hmm.
nothing. There's a middle ground there.
Okay. So you're basically saying like if I do get stuck, I'm able to like still talk throughout like my initial approach and talk about like why it could possibly work, and then and obviously like include like the reasons why it couldn't work as well, and then ask the interviewer to just chime in.
Yeah, I mean, look, yeah, exactly. Because here's the thing, right? Is let's say you can't think of anything,
Yeah.
right? Then you're cooked anyways. So the thing is
Yeah.
you gotta optimize the situation you're in. Okay. So
Okay.
if your solution is bad, right? Say that it's bad. Tell them why it's bad, right? See why it's
Yeah.
bad. See what you think could have been better. What approaches you would try. What you might think through, right? But the thing
Hmm.
is if you don't got anything, sitting there and doing nothing is the worst thing you could possibly do, basically. All right.
Okay.
Now here's the thing. Sometimes the interviewer, they're not tasked with just your pure algorithm. Sorry, they're not tasked with just measuring your pure algorithmic skills. That is rarely a relevant attribute these days, right? What
Hmm.
they're oftentimes tasked with, especially for more junior people, interns, new grads, etc., is they want to look at your attitude. They want to look at your communication skills, right? Are you able to clearly communicate why your algorithm will or will not work? Are you able to identify where the issue is, right? Identifying where the issue is the first part of solving it. Maybe you can identify it, maybe you can't solve it. Well, then maybe the interviewer can choose to step in at that point, right? So
Yeah.
having that clarity is really important. And if you don't ask for help, the interviewer will rarely step in and just start giving you stuff, unless you're like really not looking good. In which case you fail
Yeah.
anyways, so it doesn't matter.
Yeah, you're right.
Cool. Any questions about this one?
Um, no, honestly, just like thanks for the insights for sure, and yeah, I'll take a look at those disjoint sets and those
Yeah,
union.
I mean just search number of islands too on Google. It'll come up. There's a lot of answers out there. The ultimate one uses union find. If you don't know it, that's just unlucky. You're not meant to know it. That's more of an advanced structure, but you are
Yeah.
still meant to be able to come up with at least an optimization over the naive one. So that's kind of your guidance here.
Okay. Um, do you have any like tips for me outside of this? Like I understand there's a lot of like gaps within my knowledge. I've completed just like the blind 75. And
Okay.
so that's pretty much like the depth of the amount
Well, the
of
Blind
questions that I've done.
75 is it's a list. It's actually a bit old now. Now the thing about the Blind
Okay.
75, well, any list, Blind 75, Neatcode 150, any of these guys, they're just a list. It's not like
Yeah.
if you finish a list, you're guaranteed to pass every interview. No, the list is is an arguably representative set of Leetcode problems that portray the idea that it chooses to describe. Right. The thing
Mm-hmm.
is that you can't do it backwards. You have to understand. Okay, I'm doing the problems to understand the concept. Like I'm doing these 10 problems to know more about greedy algorithms or something, right? You
Yeah.
can't be like, oh, I know I did the 10 problems. Now I know about the greedy problems. No, like that's not the case, right?
Mm-hmm.
So it's not like just doing a checklist. You did the 75, boom, you're done. No, so you do the checklist and say, okay, well, think about it. Where was I strong? Where was I weak? Hey, was I too slow on these ones? Right? That's the thing. It's not like just finishing it. Were you too slow? Right? So
Was
you
I
got to
too
be
slow?
well, depends on the exact goal of the interviewer. So
Okay.
if they were looking for communication skills, they probably would have let you sit on the second problem a bit more. I mean,
Mm-hmm.
the second follow up the first question a bit more, and they wouldn't have tried to do a second problem. Because it's a mock interview, I don't care about your solution. It's not going to be correct anyways. So I just wanted to get another problem to check your understanding. So
Okay.
today's interview is not really about pacing. The pacing is not relevant for today's interview.
Okay.
Right. So, and again, a big part of it is going to come down to precisely how you practice. So
Yeah.
don't treat it as a checklist. You should treat it much more like a proxy for the topic. And so if you do the 10 problems or whatever, and you're still not there yet, you're not confident, you're not fast, then you got to find more problems.
Yeah.
So just because you did blind 75, whatever, doesn't mean that you know what's going on.
Okay. That makes sense. Do you have like a new tailored list? I
No,
understand like
I don't
okay.
do the tail list because again, a lot of people I used to do them. I used to have a list, and then people say, "Hey, I did your list. I'm still not passing." I'm like, "Dude, that's not the point of the list." So no, I don't tailor lists
Yeah.
anymore. That's not really my business.
Okay. No worries.
All right.
Um
If you don't have any other last minute questions, we'll call it here for you.
yeah, I don't have any more. Do you have like a note, a bunch of these notes that
I
you might
have
have
some of the
taken?
notes. I'll send you the
Okay.
notes after, but I don't have any notes for the second problem.
Okay.
So I'll send
No
you the ones I
worries
have.
then.
They're not very complete this time, unfortunately. I was a bit more involved and not typing enough, but I'll send you what I have.
Yeah. Okay. I appreciate it. Thank you so much. It's Leo, right?
Yes, that's right.
Okay. Thank you, Leo.
All right, take care.
Bye bye.
All right. Send the guy his notes. And then, we'll get to the second segment now. Trader JM. They've been for a while. This is what BFS is the GOAT. BFS is also not a free lunch, but, you know. BFS, DFS, do what you want. I don't care. All right. Where are we? We are here. Sheets. Oh wait, wrong sheets. Resume, reviews, responses. Here we go. Wait, where's my sheet? Form, resume, form. Wait, what? Where's is it in my description? Got a new fucking. All my shit's messed up. Oh, here's the form. Is this form correct? It is. Okay, nice. All right, let me pin the form. Submit resume. Do we have any from last time? Let's see. Last time I canceled it, so. right, we got one early guy. All right, let's look at this guy. Usually I wait the 10 minutes or 5 minutes, but let's do it here today. All right. Yeah, it looks redacted. Okay, cool. All right, so first one today, full stack, trying to focus on back end. Also interested in big data processing, but don't have anything to show for it yet. Okay, that's pretty normal though. Okay. Where am I? All right, here I am. What color should we use today? I'm using red. Oh, that's a nice fuchsia. Okay, so where the hell am I? I'm over here. You have some data. Okay, so we are like second, third year kind of coming in. Reduce chat latency response. Reduce chat response. Okay, I like. Okay, this is good. 40% faster points. Okay. Real-time log filter, ensuring compliance. Cool. Unblock the major feature release and IDP. Okay. To ring us tenant user data, minimize data loss. Yeah. This one hits close to home. I'm dealing with a lot of this at work as well, so that's pretty cool. I think this one. I mean, this one's an 8-month internship, so it makes sense. You got a lot of points here. I'm not really seeing too big of a theme throughout all of this. I mean, the points are individually pretty good. If you have a theme, like if, for example, if these were all part of one feature / launch, I think that would be good to tie in theme wise. But I think the points are strong either way, so that's not a big deal. Hold on. I'm just pinning this guy. All right. But no, I think these points are pretty good. 8 months, right? Yeah. UTA, 300 students, OOP, OD, JUnit design patterns, troubleshot. I guess that is a past tense. Three points there though. Okay. The way I'm looking at this right now is that these two both taking 3 points is probably excessive. I would probably put more points under this one if you can. And this might be the time where I would say you might want to use subheaders as well, right? Because you got 8 months. So for example, you have the company name, you have your title, and then just say like, hey, project 1, boom, like 3 points or something. Project 2, 3 points or something, right? This is a better use of space than giving 6 points to these two, which are relatively irrelevant. For example, you could probably put these two under 1 point, and that's generous too. Okay, IT support. Upgraded, reimagined, reimaged. Sorry, 20+ workstations, triple. Okay. Yeah, I mean that's cool, but this is definitely not 3 points of content. So I would say if you can expand this one out more, this is a lot more relevant. Okay, this is a club presumably, some developers. Okay, I mean like these two kind of sound like they're kind of the same thing. If you have if you have the thing linked, I would put it here. That would be good to show as a proof of work kind of thing. Projects, membership portal. Oh, is it this thing? Okay. Payments, Google Cloud Run CSCD. Okay, I see. Okay. I'll put dates here if you could, but that's chill. Jarvis, LangChain. Okay. 5+ apps using a sub-process AppleScript. Leverage WebSockets to enhance responsiveness by updating the UI with tool implications. Results LM output. Implemented a RAG pipeline. Chroma synced. Okay. This is pretty cool. I mean, this is pretty cool. I can think this could be branded as like an accessibility kind of thing. I think that's pretty cool. Technical skills, yeah, these are whatever. Okay, so I mean, look, yeah, I mean, you call it yourself data processing. I don't see anything here. I mean, like you got a little bit over here with the PII script. Um, I don't see much over here. Look, you can go big data. You can still do that kind of stuff. I would just definitely focus a couple projects on that. Right? Simple. Just do a couple projects on that, and then you're chilling. But as of right now, yeah, I think back end you're pretty good. Everything else, maybe some more products or something. All right, let's see. Ooh, no submit. Wait, is really no submissions yet? Oh, wait, calling it early today. I'll give people some time to submit, but I mean, look, I'm hungry. I want to eat lunch. So if you guys ain't gonna submit in 5 minutes, I'm going. I'm gone. Calling it a day. Let me look. Who's pinging me on Discord? Maybe some resumes over here. Let's take a look. Maybe I'll do Boba Talks or anything. Let's see. 6 days ago. 18 days ago. What the fuck? I never actually explained a gap. What the hell? That's not tech. What? Roof contract, blah blah. Looks like this guy got good advice already. May 2nd. What the frick? That channel is dead as hell. Alright. Alright, I got one more submission. I'm looking at this one. After I finish with this one, if there's no one else, then I'm done. Oh, it's not even a whole resume. Alright, what's this? What the hell is this? This is my flagship project. Oops, where's my link? You're reading my resume. This is only one with added content. I'm trying to min-max this. Is it too wordy? I don't have any previous internship experience. I aim to add back-end cloud DevOps platform role. Getting a lot of rejections from first internship. Shouldn't even bother applying to competitive companies. Also, would be okay to use a friend's phone address. That's a lot of questions. Okay. Is this too wordy? Let me take a look. With plus 15? Do you mean 15 plus? Logs data to Google Sheets, MySQL database on Cloud SQL. What is the relevance of Google Sheets here? Like just get rid of this. Get rid of this. Enabling Discord bot to post daily tracking and leaderboards. Okay, I will rephrase your first point. But the Chrome extension that enables a Discord bot to post daily tracking leaderboards using XYZ. You know, talk about the impact first. Build on GKE. Okay, that's chill. That's chill. I'm gonna GKE single G. Okay. Wait, what? By SSHing in and configuring Docker Compose, you configured it on the host itself? I don't know if I would advertise that you're using SSH manually, but points otherwise okay. Sure. FigJams. Okay, I think these things are good. I think these are good. I don't think it's too verbose. I would just rephrase things. All right. Blah blah blah. For first internship, should you even bother applying to competitive companies? I mean, you should bother to apply if you think that you have a chance. Frankly, getting rejections doesn't really mean anything too negatively. But the reason I'm saying realistic is because sometimes if you apply and they reject you, you might be put on a cooldown. Right. So if you believe that you're gonna get much stronger in like 6 months or so, then maybe hold off on applying so that you don't get put on cooldown. Would it be okay to use a French Toronto address and want to move your own expense? I mean, I don't think people care about that, to be honest. I guess, wait, okay, where are you from? Okay, I won't say it, but I see over here, I guess. Wait, is this where you're from? Oh, no, that's a different row, sorry. Okay, I mean, that's not a bad city. You're probably going to be okay. I don't think putting Toronto down a resume would really help, to be honest. That stuff doesn't really matter. Okay, what is this? Let's look at this guy. All right. So this guy says mainly targeting backend, only have volunteer experience. All right. Coursework. Okay. I mean, probably wouldn't put volunteer under experience. That's just me, but that's a bit misleading. Optimize, improve. Okay, what's number there? For okay, you did a reverse proxy. Collate weekly development meetings to. Okay. All right, all right. Decreasing manual work by 50%. I would more phrase that as like decreasing time spent on manual work or something by 50%. You know, like measuring work itself is difficult. Connected code reviews. I think this is like a bait. Like this, I don't know. Like I'm torn on whether or not you should put this as a point. Like on one hand, you don't have any points here, so it's gonna put some stuff down. But on the other, um, I don't know. Like on the other, like this is like it's like this is such a basic thing. Like I don't know if this looks bad in the sense that like it feels like you got to say the basic stuff, which means that you have no room for all the good stuff. I don't know. I'm torn on this one. I probably would take it out though, to be honest. Okay, so we have links. Links are good. I would put dates though, right? Like you need dates as well. If you have a GitHub, then you have the date anyway, so just put the date in there. All right, so Spring Microservices API, fitness app, 30% of peak loads. I can believe that. I would probably describe peak load because this is a project and it is unclear what the consumer is. Implement a secure OAuth 2, key cloak, that's fine. Service discovery, API gateway, Eureka, blah blah. Okay. Multiplayer networking game. Design implemented team of 4 TCPs. Okay. Sure. Food Connect. Food. Led team of 4 is a Scrum Master. Google Hackathon, weekly meeting, sprint planning, task coordination. Okay, what is going on here? Okay, I'm gonna read this faster. This is not okay. Blah 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 blah. Okay, blah. Okay. So what you have here is you have no in-depth project. Okay, you need to do more in-depth projects, especially ones that don't have other people just always on the project. It's not that it's bad to have other people in the project. It's that it is unclear what you did, right? Your work, your contribution on the project is unclear, right? But if you instead choose to clarify specifically what your role was, then I think that's actually maybe doable, right? Here's the thing. On this one, for example, you're talking about being a Scrum Master. Look, that's very cool. You're going for entry level roles, right? Scrum Master is an irrelevant skill set for what you're trying to do, right? So best case, people see this and they're like, oh, you know what, this person was trying. That's great. Worst case, they go like, oh, this guy is completely misguided on what their priorities are. So I would say, I'm not telling you to take it off. I'm telling you to be very explicit about what your contributions were, especially from a technical part, like from a technical basis. So just consider that. All right, next one. Looks fine. Oh, I copied the wrong one. All right, just copy it again. All right, this person's comment: open to multiple different roles, including data engine and automated automation processes. Okay. SDT, present, data eng. This intern? No, this is full time. What is the person's goal? Open to multiple different roles, so they don't have a specific goal. All right. Complete the final. Complete. This is a non-conjugated verb. You probably want to conjugate that one. Some DLH environments. Okay. Build internal tools. Okay. Okay. Python animations. 10 vehicle programs. ECUs. Jira test rail. That's probably okay if you talk about FSO. Root cause analysis, deployment failures, analyzing domains. Okay. Identify issue manifest software. Okay. Okay. Develop in-depth knowledge for software release vehicle. Okay. I probably wouldn't talk about this as much. This is like more of a show don't tell. But these ones I think you basically have to tell. Like you can't show that, especially at this level. So I think overall it's pretty good. Data Eng, intern, Python automation, SQL Academy, SQL stuff, API stuff, optimizing lifecycle. I would quantify that. What does that even mean? Best practices guide. That's good. Create and manage 15 pipelines. That's pretty cool. Coordinated, develop 3 more than 3. So 4. But more than 3 you mean 4. Just write 4, dude. Optimizing existing dashboards. Sure, I would. Well, now it's a bit late to quantify that, but again, if you can't quantify an improvement, you didn't improve it. Okay. Python, Java, JavaScript, some stuff here, yada yada, lowercase s. A lot of, oh, SSMS, holy, okay. Graduate 2024, okay. Okay, cool. Resume is fine. I would probably spend your time optimizing the time you spent outside resume, so passing interview loops, networking, etc. Resume is fine. I mean, there's obviously stuff to improve, but I'm not gonna sit here and rattle this off. Like the resume is gonna be fine. All right, back end and cybersecurity. All right. Oh, my favorite Florida person. Okay. Okay, so you have full-time experience since when? Intern. Oh, since recently. Research assistant. Okay. What is this? Interns. Okay. You're at the point now where basically you don't want to spend as much room on projects, probably, unless they're more recent. Now, this one's recent. These aren't recent anymore, especially this one. What does super mean? I probably won't use adjectives there. That's a lot to do in the 1 month you're here. That's good though. That's fine. That's fine. Wouldn't put that there. Like you gotta cut some of the stuff out. This is not relevant, especially if that's long ago. Yeah. So going forward, a couple things you gotta do. So right. So this one, put like over here, first place, and then get rid of these 2 points. Not relevant. What is this? Was this a hackathon? What is? Wait. You're going for backend and cybersecurity, so I would just get rid of this project. Implement a resilient crypto platform. Okay, this is ongoing, so you can keep this one around. Like this is fine. You know, as you get more stuff here, you can keep it cool. That's no problem. Most importantly is like when you get more experience here, just put more points over here. This should just split that up. Everything else is fine. Full stack infra DevOps. Okay. Look, lowercase, very nice. Okay, this is good. Those are good. That's fine. That's good. A lot of yapping here, but this is more than a year. More than a year. Let me see. Okay. All right. ETL analytics. What is this? Some rollback stuff. What is this? Bug reports. Okay, so there's not really a big theme here. Okay, then that's fine. All right, you've been here, sir. You've been here for like a month, 2 months now. Okay, that's good. Cross-platform, mobile testing, building reusable automation. Okay. This is a weak point. I don't know if I keep that around. That's a weak one. Validate new features, blah, blah. Okay. Ensuring high quality releases. Okay. Yeah, I feel like this is either 2 points or not understanding. Like how is this related at all to releases? Like I don't understand. I would probably split that one up. I would probably split that one up. Yeah, everything else is kind of about average. It's fine. Yeah, I mean you are here full time now, so as you get more experience, this will be by far the most important thing. Because this is more than a year old, even right now it's more than a year old. By the time you look for your next job, this will be more than a year old, right? Alright, this person has clearly not read the instructions. Let me see, where are they from? Okay. Alright, that's all. Oh, hold on, what's this guy? Oh my god, guys, I can get cheap viewers on streamboot.com. Holy cow. Holy cow, that's what I really want on my 10 viewer stream. I really want cheap viewers. How the fuck do I report this guy? Report this guy. Terrorism. No, not terrorism. Where's like search? I can't report for spam. There's no spam. Oh, here it is. Okay. Spam. Yap. He yapping. Submit report. Boom. Done. Alright guys, get out of here.